Okay, so we're graphing this particular function. We're graphing it because we need to do maximal domain and range, point of inflection, and then find the rule of the inverse. So I've got this composite function happening that x goes through 2x minus 1 first. Then it goes through the inverse sine of x, and then after that, plus pi on 2. So the thing that goes into the inverse sine of x is negative 1 to 1, and what will come out will be, so the inverse sine looks like this, minus pi on 2 to pi on 2, but then when you plus pi onto it, 0 to pi. So my range should be 0 to pi. For what coming out of here to be negative 1 to 1, so that it fully fits in through here, then I've got to have 2x minus 1 has to be between negative 1 and 1. Plus 1 to everything. 0 has to be 2x up to 2, divided by 2, 0x up to 1. So my range is 0 to 1. So maximal domain, 0 to 1, range. So my graph's going to look like this. 0 to 1, 0 to pi. Point of inflection, because of I know that the curve is going to have its point of inflection there, it's going to be dead middle. So 1/2 and pi on 2. So it's coordinates. And then the rule of the inverse. Okay. If x equals the inverse sine of 2y minus 1 plus pi on 2, x minus pi on 2 equals the inverse sine of 2y minus 1. 2y minus 1 equals the sine of x minus pi on 2. 2y equals the sine of x minus pi on 2 plus 1, and y equals 1/2 the sine of x minus pi on 2 plus 1/2. So that is the inverse. Now keep in mind that we have in actual fact a half sine of minus pi on 2 plus x. Minus pi on 2 plus x is in the fourth quadrant. Sine in the fourth quadrant is negative. And I know the sine of minus pi on 2 plus x is the same as the cos of x. So in this case, it will be the same as the negative cos of x. So I could write that as negative 1/2 cos of x plus 1/2. Either of those answers will be acceptable inverses. So that's A, B, and C.